All right, welcome to class, everyone. We're going to start with our bell ringer, so take a second, take out your pink sheet, and start on this. You can pause the video for a little bit. All right, now that everybody has their answer, let's go over it together. So trade your papers, and we can start. So we need something that looks like this, y equals kx. We know from yesterday we find k by taking y divided by x, so 16 divided by 4 means our k value is 4. And so y should equal 4 times x. And that's our direct variation equation here. So give your partner a circle or an X, trade your papers back, and then take out your notes for today. You're also going to need a graphing calculator. So if you don't have one, grab one from up front in the apple basket. Or share with a neighbor, but everyone needs to have a chance to look at a graphing calculator. So we're going to be talking about scatter plots today and lines of best fit. So we're going to start just by filling out a scatter plot. So we're given some data right here based on laws that set 21 years old as the minimum drinking age and how many lives that these laws have saved because of traffic fatalities. So we're going to just start by plotting these points. We're already given a graph that we can plot them on, so we don't have to draw a graph, which is super nice. We just have to plot these points. So each pair is a point that we'll plot together. Years is our x values, lives is our y values, and we can plot it from there. So in 1999, about 19.1 thousand lives were saved. So I'm going to say that point is about right there. In 2000, about 20,000. So I'd say that's about right there. 2001 is 21. We'll plot that point right there. 2002, 21.9. Pretty close up there too. And 2003, 22.8. Still just a little bit higher. And there we go. So we plotted all the information. Next, we need to draw in a line of best fit, which means we need to draw a linear line that gets really close to all of these points. So we're just doing our best. I'm going to say something like that looks good to me. Next, we need to describe the correlation. So we either have positive or negative correlation, and it's either strong when it's really close together or weak when it's spread apart. So all these points are pretty close to that line, and it's moving in a positive direction. So I'd say this is strong positive. And then next we need to write a prediction equation. Now this does not need to be exact. We're just going to kind of guesstimate. So we're going to try it one way in this question and try it another way in the next question. So we're going to try writing a prediction equation in slope-intercept form. So we need to think about what is our slope, or what is our rate of change as we go up here, and then where do we cross the y-axis. So my slope as I go up here, as I go up by 1 year, it looks like I go up about 1 on my y variable as well. Not perfectly 1, but pretty close. So I'm going to say 1 is my slope. And then my y-intercept, let's see where we cross. It looks like it's a little under halfway between 15 and 20. I'm going to say that's about 17. So this is my prediction equation right here. It doesn't need to be exact, just something that might be close. And then E is saying use this equation to predict the number of lives saved for the year 2015. So our y-axis looks like it starts at 98. So we need to think how many years after 1998 is 2015? We know that that's 17 years later, so I'm going to put 17 in for x, and we're multiplying that by 1. So 17 plus 17 gives us 34. So about 34,000 lives would be saved in 2015. All right, we're going to talk a little bit about correlation and then how to find a line of best fit if what we just did seemed a little confusing. We're going to break down another way that we can do it, and we'll do that on the back page. So scatter plots have one of three types of correlation, either positive when it goes up, negative when it goes down, or no correlation when it just seems to be pretty random. And we have what's called a correlation coefficient. So that's a number anywhere between -1 and 1 that describes how close together our dots are on our graph. So right in the middle at 0 is our no correlation point. And anytime we have negative correlation, it becomes negative. Anytime we have positive correlation, we are in the positives. So as we get closer and closer and closer to a perfect correlation, it's going to get closer and closer and closer to either +1 or -1. If we have a negative correlation, we'll get closer to -1, and likewise for our positive correlation. These numbers at the bottom are our correlation coefficients. So perfect correlation will have either 1 or -1. High correlation, so really close together dots, will have 0.9 or -0.9. And low correlation will have either 0.5 or -0.5. So we'll use that a little bit in a second, but let's break down a way to find a prediction equation first. So a good way to do this would be to pick 2 points that we're given. So we're given a table with points in it, so we're going to pick 2 of those. And with those 2 points, we're going to find our slope. So remember, that's change in y over change in x. And then using the slope and one of your points, we're going to put that into y minus y1 equals m times x minus x1. So this is an easier way to break down a prediction equation. Let's look at these. We're going to be stating the correlation coefficient for these. So when I look at my first scatter plot here, it looks like I'm going down in a negative direction. So I know my correlation coefficient will start with a negative, and it seems like it's pretty spread apart. So I'm going to say this is low negative correlation, which would be -0.5. For our second one, we're going up, which means I'm going to have a positive correlation, and it looks pretty close together. Not perfect, but almost. So I'm going to say this is +0.9. All right, we have 2 more, and then you will get time to work on stuff. For number 2, we are going to draw a scatter plot, describe the correlation, and then find a prediction equation. So as we draw this, you can label your axes the same as me. So I'm going to start at 1994. So I'm just going to abbreviate that and write 4. And I'm going to go up by 2 years because it looks like we're going up by 2 years up here as well. So it doesn't need to look perfect, but something like that. Years are going to be our x value, price is our y value. And on our y-axis, I'm going to start us off at 130, and we're going to go up by 10 each time. So that's 140. I'm not going to write all of these in. Maybe every other. 180. 200. And 220. That looks to be about good. Now we're going to graph these points. So 1994, we're about right here. Next point, we'd be about right there. 98, close to here-ish. 2000, pretty close to 170. 2002, 187. That looks to be about right there. 2004 is a little bit higher at almost 220. So I graphed my scatter plot. Now I'm going to draw in a line of best fit. I'm going to say something like that looks pretty close. Describing the correlation, we're definitely going up, so it's positive. And I would say that this is a pretty strong positive correlation. And the last step we need to do here is find a prediction equation. So we're going to do it like we wrote down on the front page. So I'm going to pick 2 points. I'm going to just pick these first 2, and I'm going to find my slope. So my change in y looks to be 10. My change in x, we already said, was 2. So my slope is 10 over 2, which simplifies out to be 5. And then I'm going to use one of those points in my equation. I'll just use the first one. So y minus 130 equals my slope times x minus 1994. All right, and then the last step to this is using this equation to find the price in 2004. So I'm going to plug in 2004 for x and compare that answer to what my table gave me. So I have y minus 130 equals 5 times 2004 minus 1994. And I will do that math out to see what we get. 2004 minus 1994 gives me 10 times 5 gives me 50. Then I want to add 130 to both sides. I'm going to get y equals 180. Now that's not perfect, but it's pretty close. So we're going to call that good and move on to the next one. This is the one where we're going to need a calculator. So make sure you have a calculator and take out that sheet of paper that the substitute handed out at the beginning of class that shows us how to find a linear regression in our calculator. So instead of estimating a line of best fit for this scatter plot, we're going to be putting it into our calculator and finding the most perfect line of best fit we can. So let's start by graphing everything. I'm going to label my x-axis going up by 2. And my y-axis, I will let's start at 70 right here and go up by 5s. So this would be 75, then 80, and 90, and up here, 100. So we're looking at some scores based on how much students studied. So our first point, we have a student that studied for 5 hours and got an 80. So we'd put a point right there. A student that studied for 9 hours and got a 95. We'll put a point right there. 3 hours and a 75. 12 hours and a 98. And then 1 hour with a 70. So we have a scatter plot right here. And the rest of this we're going to be using our calculator for. So we're finding a line regression. In order to do that, you need to take out your calculator, and there's steps in front of you that you can follow, but we'll do it together. We're going to click Stat, Edit, and then we're going to put in our points into our list. So I'm going to start with all of my x values. So 5, 9, 3, 12, and 1. Oh, that wound up not being 12. 12. There we go. And then I will put in all of my y values. 80, 95, 75, 98, and 70. From here, I'm going to click my Stat button again, and I'm going to arrow over to Calculate, go down to number 4, which stands for Linear Regression. I'm going to click Enter. I need to make sure list 1 is my x variable, list 2 is my y variables. I'll click Enter a few times, and once I get down to Calculate, that's the last time I'll press Enter. And right here I have a line of best fit. So instead of using m as our slope, it uses a, but it tells us that our slope is 2.725 and our y-intercept should be 67.25. So we can write that down over here. Our slope is 2.725. Y-intercept is 67.25. And so our equation should be y equals 2.725 x plus 67.25. And we have a perfectly calculated line of best fit right there. And our very last problem that we're going to look at is to predict what score a student who studied 10 hours should be. So I'm going to put 10 in for x and see what we get. So 2.725 times 10 plus 67.25. I will put that into my calculator and then see what we get. They should have received a 94.5, and that seems like a pretty good score to me. All right, you guys can spend the rest of class working on your homework. Make sure that you keep that sheet that the sub gave you to explain how to do this, because you're going to have to do this on your homework. Have a great day.